Hello student, welcome to lesson 1 where we are going to look at production of cathode rays and cathode ray tube. We have that when a metal is heated at a very high temperatures, electrons gain kinetic energy, and that kinetic energy is enough for them to break loose, and therefore they are able to be released from the metal surface, or they are emitted from the metal surface. That process where we have that the electrons are being emitted from the surface of metal, that process we call it the muonic emission, as we are going to see the definition later. Now the electrons that are released when they move in a stream or when they are attracted by anode, they form what we call the cathode rays. So cathode rays are defined as streams of electrons that are moving from cathode to anode. Remember, cathode is the negatively charged plate and anode is the positively charged plate. So cathode gives us the electron, then anode attracts them, and when they are attracted they move in a stream, and that gives us what we call the cathode rays. Now the process where now the electrons are emitted due to heat is what we are calling the muonic emission. We are going to see its definition here, that it is a process of emitting electrons from a metal surface due to heat energy. We can be able to demonstrate the process of the muonic emission using the following circuit. In this circuit, as shown in the diagram, we have evacuated glass tube, and this evacuated glass tube has the cathode, as you can be able to see here in the diagram. This cathode is made of metal oxides of low work function. As we are going to see later, the work function is defined as the minimum amount of energy required by a metal to release its electron. And therefore we are saying that it has a low work function, which implies that if a small amount of energy is applied, then electrons will be emitted easily. Also in the same evacuated tube we have the anode. As you can see, anode is connected to the positive terminal. Then we have the myriammeter here. This will help us to show or to observe whether there is current that is flowing. As you can see again, the cathode is connected to the negative terminal. From here we have the heater filament that is connected to another source of heat. So the work of this heater filament is to heat the cathode. And when the cathode is heated, it releases electron. We are saying that a low voltage of about 6 volt is connected to the heater filament, and this heats the cathode. When the cathode is heated, then we have electrons being released here. And before the heater current is switched on, remember we are supposed to observe what is happening in our myriammeter. So before this switch is on, the myriammeter has no effect, or there is no deflection. There is no current that is being registered. But when the heater current is on, that is the switch is switched on here, we find that there is current that is being registered in our myriammeter. Now what happens is that when this one is heated, the cathode, it releases electrons. Those electrons are attracted by the anode, and as they move, they form what we call the cathode rays. As they move, they complete the gap between the electrodes, and therefore the circuit is complete, and that way the current will be flowing. That is why now we are able to observe some current being registered in our myriammeter. Then from there, we move to the production of cathode rays. And in here, we have what we call the cathode ray tube. As you can see, we have the cathode, we have the anode, we have the evacuated glass envelope, we have the screen, and then we have the external source of heat here. As again you can be able to see, this positive is connected to the anode because anode is positively charged electrode, and also the cathode is connected to this negative terminal. So what happens is that when the cathode is heated, electrons will be emitted through what we are calling the muonic emission. And the electrons that are emitted here will be attracted by the anode, because the two, they have what we call the potential difference between them. As you can see, we have extra high tension source that is being supplied here. So between the anode and the cathode, we have a very high potential difference. So that is why now the electrons that are emitted here are attracted by the anode. Again, we are saying that the tube is evacuated, or we have ensured that there is no air particles. And this will help to ensure that the electrons do not collide with any air particle. Because if they do, if they collide with air particles, they are going to lose some of their kinetic energy. Because as they collide with the air particles, they are going to ionize those air particles. And what is ionization? We say that this is a process where electrons are completely removed from atoms of an element. So if the cathode rays are colliding with the air molecules, then they are going to ionize those air molecules. And by so doing, they lose their kinetic energy. So to prevent that, that is why now the vacuum is created, or the tube is evacuated. So the cathode is coated with barium and strontium oxides. And this one, we are saying that they have low work function. So in other words, they are able to give electrons easily. From there, we move to properties of cathode rays. One, they travel in a straight line. And this can be demonstrated when you put an opaque object on their path. For instance, in our diagram here, we have the anode here, we have the cathode. So the cathode rays are being produced and accelerated by the anode. But in between the screen and the anode, we have an obstacle here. So as they move, we see the shadow being casted on the screen, which implies that they travel in a straight line. Then number two, they are particulate nature. In other words, they are particles. And we are saying that they are negatively charged particles, because cathode rays are electrons. They are electrons, and electrons are negatively charged. Therefore, they are particles. They have what we call the particulate nature. Then number three, they are charged. We are saying that they are electrons. Electrons are negatively charged, and because they are charged, then it means they are affected by both magnetic and electric field, which implies if one, they are moving in an electric field, they are always attracted towards the negatively charged plate. Like for example, in our diagram here, these are cathode rays that are moving in between two charged plates. This one is negatively charged and this one is positively charged. And because these cathode rays are negatively charged, they are going to be attracted towards the positive plate. So that is why they are deflected towards this plate. Then, if they are moving in a magnetic field, we always use what we call the Fleming's left hand rule. And in this rule, we use our left hand. In our left hand, we consider the thumb, the first finger, and the second finger. Those three fingers are put at right angle. In other words, we are saying the first finger is at the right angle with the second finger and with the thumb. Then when that happens, the second finger will point in the direction of current. And because here we don't have current, we always look at the direction of cathode rays. Cathode rays are electrons. And if you remember in the simple circuit, we know that electrons always move from the negative terminal to the positive terminal, where current, or again, the current moves from the positive terminal. So in other words, the direction of current and that of electrons are always opposite. They are always opposite. So it implies if cathode rays are electrons and they are moving in this direction, then the current will be in the opposite direction. And that is why now we are saying that the second finger should point in the opposite direction to the cathode rays, or to where the cathode rays are coming from. So if the second finger is pointing in the opposite direction of the cathode rays, and then the first finger is pointing in the direction of the magnetic field, then the verb will give us the direction of motion or the direction of deflection, and that way you are able to know where the cathode rays will be deflected. For instance, in our diagram here, we have the magnetic field represented as X, which implies that the field is away from you. It is pointing inside the paper, or in other words, it's away from you. So if you point using your second finger, and this one you're supposed to do it practically, if you point the first finger away from you and then the second finger pointing in the opposite of the direction of cathode ray, then you find that the verb will point downward, showing that the cathode rays will be deflected downwards. From there we move to another property. They produce phosphorescence. In other words, if they fall on certain materials, then that material glows. And in our case, we have what we call the zinc sulfide or phosphor. And this is the material that is covering our screen. So that now, when the cathode rays falls on the screen glows. And what you observe is that a bright spot is created. Then from there, they possess kinetic energy. Remember, these are particles. And whenever we have particles that are moving, then they will have what we call the kinetic energy. That kinetic energy is converted into light energy when they fall on the screen, and that screen now glows. The main reason why the screen is not heated, because the screen changes that kinetic energy into light energy. Then they have momentum, and the momentum will be given by the mass of electron multiplied by the velocity. The kinetic energy will be given by a half mass of electron multiplied by the velocity squared. Then the kinetic energy of electron is equivalent to the work done by the electric field on that electron, and therefore that kinetic energy will be given by EV, where E is the charge of an electron multiplied by the volts. Then number 5, if these cathode rays are stopped by an obstacle or what we call a target, then cathode rays produces X-rays. Then they are affected by photographic plates. Then number 7, we are saying that they can ionize gas molecules if they collide with them. And that is why we said that in our tube, the tube is evacuated to prevent them from ionizing air particles and that losing their kinetic energy. Then finally we have the assignment. Make sure that you attempt all the assignment. It is just testing what we have just covered. Ensure that you read, you recite, you reflect, you share your knowledge with your peers so that you can be able to attempt the assignment and get them correctly. So thank you, and let us meet in our next lesson.